how can we identify areas for improvement? Let's start by looking at our application architecture and considering which elements might be underperforming. It's helpful to start by doing error analysis and finding out at which point our models break. We can use a tool like W&B Tracer for this. Starting from the left, we don't have much influence on the quality of user questions, but we could improve the user interface by providing helpful messages and guiding users to ask specific questions. A frequent root cause of errors is the document search. Our embedding model might not retrieve the relevant documents. In such case, we might add a keyword search, train a custom embedding model for our dataset, or explore different similarity search methods. If the model struggles to provide a relevant response, it may be also due to insufficient documentation. In that case, improving the documentation can be a useful solution. In fact, when analyzing wrong or missing responses by one bot, we often find that the best action is to update our docs. The prompt template can also have a significant impact on model responses. We'll discuss prompt engineering techniques that can steer the model to produce the desired output. We can also experiment with using different LLM models. We can try various APIs or potentially train or fine-tune our own custom model. Finally, we can adjust sampling parameters such as temperature or top P. Let's now explore various strategies and ideas to enhance our application, starting with document search. This is often considered a bottleneck in many applications. We can identify specific problems by analyzing errors. Usually, when we understand the root causes of our model's errors, we can also find an adequate solution. One issue that can arise is that certain words, like proper names or new terms, might not be well represented by embedding models. We can fix this, for example, by combining embedding search with keyword-based search methods. Another problem is that questions and answers may be far away in the embedding space, making it difficult for embedding models to find the right match. A solution to this problem is using hypothetical document embeddings, where a large language model generates a hypothetical answer to a user question, and then that answer is embedded and used to search for relevant documents. A third issue is that with a limited number of documents in a prompt and large number of similar documents, the retrieved documents may lack diversity. In such case, we can use maximal marginal relevance or MMR, which helps balance relevance and diversity. This increases the chance that we'll find the right answer in the prompt. And lastly, domain-specific questions and documents may not be represented well in generic models. Here, training a custom embedding model on your data, which is designed for your domain, can improve performance. In our baseline solution, we use a simple chain called stuff. It's advantageous because it's simple and we need to make only one call to the LLM. However, we can also experiment with alternative chain types, which are available in LangChain. Let's start with MapReduce. In this case, we run an initial prompt on each chunk of data to extract relevant information, and then we combine it together in another LLM request. In the refine chain, we run an initial prompt on the first chunk of data and then refine it by adding new chunks in consecutive LLM requests. In the map re-rank chain, we run an initial prompt on each chunk of data, and then we rank the responses based on a certainty score and return the highest scored answer. And these chains can lead to better results, but they also increase costs and latency. And we need to balance user wait time, costs, and additional value from these advanced chains. Another option we have is experimenting with different LLMs. Beyond OpenAI, you can explore other providers like Cohere, Anthropic, or Hugging Face Hub, which includes open source models from Meta, MosaicML, and Eleuther. Prompt engineering is an important aspect of building an LLM application. It's an active research area. There are plenty of techniques that are worth exploring, such as chain of thought, tree of thoughts prompting. In the links below, we provide various resources that can help you get started with your prompt experiments. Beyond the research, there is also lots of tribal knowledge, and this makes working with LLMs similar to practicing alchemy. We encourage you to experiment with these techniques, log your results, and use proper scientific methods to evaluate their effect on your application. Hopefully, this gives you a bunch of ideas to develop, optimize, and improve your application. In the next videos, we'll take a detailed look at evaluating the effects of our improvements.